right, good morning. All right. So, first session of the week. How many people did tectorials yesterday? Fair amount of you? Okay, so it's second session, sorry. And I actually see some familiar faces who are in my tectorial. By the way, this is going to be kind of the same. But and I've talked to a few guys up front. Who's their first Cisco Live? All right. So the good news is you have no idea whether this is going to be amazing or it's going to be horrible. But I promise it's going to be pretty amazing. So welcome to Advanced Wireless Troubleshooting. Oh, sorry, you're in the wrong room. That's an important session, actually. So obviously you guys can read. My name is Sean Wargo. I'm a principal engineer with the Enterprise Network Business Unit. Whatever that means, it means that I've been in Cisco for 20 years. This is my 20-year anniversary. Thank you. I know it seems like yesterday. So I work on, all that really means is I work on like the next generation stuff. And so I work on Cat9K. Anybody have Cat9Ks? That's good to hear, because I'm going to talk about Cat9K as well. And then, of course, I work on software-defined access. So this particular session is intentionally the first session of the entire week. And I like to call it the fundamentals. And I don't know how well the back of the room can see, but I actually like this configuration. I kid you not. I've had rooms that were like the opposite, where the back of the room was, the rectangle, and, you can't even read. So this is me way over here. This is you guys in this very first session. And the reason is fundamentals, right? My job is actually pretty easy, but it's the most important of all the jobs, because as you get off into the other sessions, I'm going to explain the key concepts, the key elements, and why they're important, and a bit about the technology underneath. But the other sessions expand from there, and they assume that you understand those key concepts, right? So if I do my job, then all the rest of the sessions will make sense. I'm not going to read off every single one. I'd waste half an hour just talking about that. But the idea is that you can, it's like a subway map, right? I could stay basically on the same line, and I would get most of the key things. So like the next session later this afternoon about connecting outside, that's about connecting outside, go figure, right? I'm going to talk about the fabric. They're going to talk about, okay, now I want to connect the fabric to other things. Now, the blue ones are more of like the advanced topics, and they get into like integration with SD-WAN. They do some troubleshooting. The red is more about security and policy. I'm going to touch on all these topics, but it's the fundamentals of all these topics, right? And then the yellow is dedicated to wireless. Now, since a lot of you guys are new, and I don't know if anyone ever explained it, the last three characters are what we call a track. So there's actually dedicated tracks to wireless. So you're in the CRS track right now. That's part of how I decided what to do. SEC is security. ARC is architecture. There's some different ones over here in NMS and those kind of things. Okay? But you get the idea, right? There's a whole bunch of sessions. This is the fundamentals. Now, my clicker's giving me grief. There it goes. But it clicks like 3 times. So I always like to spend a little extra time on the agenda. Why? Because, this sets expectations. You have a sense of kind of where we're going. And it gives me a time to catch my breath, right? So the first part is really kind of the marketing, fluffy part. Why do I care, right? But I got to go through it. It's fundamentals. I assume everybody came to this session because it was important to them. Has anybody never heard of SDA and they're in this room? Okay, so point is I will spend a very small amount of time on it. And I also came up with this cute little widget thingy up here, and it just says, complexity in one direction and time in the other direction. And you'll see it again. Just to give you a sense that, look, I'm going to spend a little time on it, but I'm not going to spend a lot of time, and it's not very complex, right? Now, on the other hand, what's most important are the key concepts, right? And I'll make a lot of automobile analogies, right? You don't need to understand precisely how a fuel injector works, but you have a pretty good idea of what the fuel injector does, right? You You have a pretty good concept of how the brakes work. You have a pretty good concept of how the steering wheel works. That's what this section is about. Truly just the concepts without getting too deep into precisely how they work, okay? But I know all the different pieces so I can build that car that is SD access, okay? From there, we'll get into the fabric fundamentals and also my little time graph, right? That's actually, we'll spend a lot of time in there. If I really, believe in fundamentals and just talking it through, you guys are gonna ask questions. We're gonna spend a lot of time in that part, right? Now, the next biggest part is this fabric fundamentals, right? Because really this session's about SD access and about the fabric. The reason I make this point is there are entire sessions on DNA Center, okay? There are entire sessions on Cisco ICE and other related topics, right? The value of coming to this session is to learn about SD access, right? Okay, and the fabric. Now, it is true and inescapable that part of SD access is these controller elements, right? So I have to talk about them a little bit. I'm just not gonna go super deep, okay? Now at the tail end of this, I don't have a magical widget about it. If time works, and I'm making this caveat on purpose because it really depends on you and I and how many questions we have, if I have time, I'm gonna do a live demo for you guys, okay? If I have lots of time, it'll be a long demo. If I don't have very much time, it's gonna be the fire drill, okay? But at least you'll get to see it, right? And the reason I made this point is picture's worth 1,000 words. I can ramble for hours, but it's just as easy to show you and you'll totally get it, okay? And then last but not least, some takeaway stuff, things to remember, and so on, okay? So let's kick it off, starting with the key benefits. Like I said, short and sweet, why do I care, okay? Now, you may or may not have seen this picture here on the left. This is the, marketing certified picture for intent-based networking, okay? Now, I like to start with this one because, we just throw up these fancy pictures and you're like, I don't know what the hell that means. But what they're trying to convey to you is two parts, right? The topmost part is the controller layer, right? And this should, like what I described to you in the agenda, immediately seem, oh, okay, that makes sense. There's a controller layer, and then there's an infrastructure fabric layer, right? But what's really important when we think of it in traditional networking terms, and again, we are gonna get into the weeds, okay, by that third or fourth section. So, what is actually happening on the routers, switches, and wireless, and how does the controller do that, okay? Now, I won't beat that one to death because the next slide kind of really gets into the details. So this is the kind of like generic marketing picture for the SD Access fabric. I'll explain why you see these little cloud things and whatnot. But you can see there's some switches, there's some routers, there's some clients going on, there's an outside, and then that controller layer, right? Now, when I talk about SD Access, and I always believe in like simple memory things, you're gonna forget 99% of what I'm gonna tell you, right? But you're gonna remember specific things, right? So this is one of those specific things I want you to remember, okay? It really comes down to these three basic things, okay? The first being a single automated network fabric. Now that's easy to say. There are other fabrics out there. I was talking with my friend here. There's ACI. The competitors have fabrics, right? What's different here is it's built for the campus and specifically integrating wireless into that fabric, right? I can have wireless. In fact, wireless was one of the first people to have a graphical user interface and build a logical topology on top of it, right? But it was a different thing. You had to do the wired network, and then you went over and you did the wireless network, right? So what I'm saying here is bringing all that together into a single automated interface, okay? So that's the first value. And we've had automation, so that's in itself not that exciting. The most valuable one is this second one, identity-based segmentation, policy and segmentation. I'll talk through all these, don't worry. But it's super important. Like if I'm trying to tell the boss, right? You're gonna go back and you're gonna say, hey boss, you spent a bunch of money, I'm down here in San Diego having a good time. Here's the 3 things I learned, okay? And this is why you want it. So it's and the part I stress on this is the identity-based, right? It's not like security's new either, right? But when we talk about intent-based networking, what we mean is, I wish there was a way to easily identify some people and some things, and I can build some logical security policies And I don't have to think through these complex IP addressing, this subnet, that VLAN, and so on, okay? And how does the fabric make that possible? Okay, so that's why it's, in my opinion, the most important of the three. Now that's just turning things on. That's just bringing up the network, day one, right? I've got to manage this network for the next 2 or 3 years. So we always say automation is not enough. I need automation and management. The DNA word is assurance. Another thing that we're launching here in Cisco Live is artificial intelligence. I don't really like that term. But machine learning, machine reasoning engine, right? So suck in a bunch of data, and it's not, again, data is not new, management's not new, but you would have them in different places, and you, the human, would have to go over and put all these pieces together. Now imagine all this data is coming back to the same place that the automation engine is. So now it itself can start making predictive analysis and updating quality of service and these kind of things, okay? So those three things are what make SD-Access and why you care, okay? All right, short and sweet, like I said, right? Okay, so what actually is SD-Access? Now, when we started this journey, around about 2016, we released a product called Campus Fabric. Has anybody heard Campus Fabric? A couple few of you? Okay. When you think of the actual protocols and what's happening on the routers and switches, it is in fact Campus Fabric, okay? It's like OSPF or BGP, it's a protocol, it tells you where things are and that kind of stuff, right? And I build the fabric, cool. But if I did that, I'd have to do it all by command line. Or if I'm savvy, I wrote some scripts and the scripts did it for me, right? And, like I've said a couple times, ICE is not, security's not new. Maybe you have an automation system. The example I gave, we released APKM. Anybody used APKM? Just curious. See who's awake. A couple folks, okay. But there are other examples. It's just an automation system, and that's its only job, is to go out, program some stuff, and it's done, right? And then maybe you had some management system, right? The example I use is Prime Infrastructure. Maybe you have SolarWinds or something like that, right? But the point I'm trying to make, it's actually the last sentence down here, is they were all separate, right? And again, the human would have to go to each one of these elements, right? Long after, you also had to go out and program each and every one of these with the appropriate protocols and addressing, right? So now it's this huge monster thing, and it's not very cool. So the punchline is the subtitle. SD-Access can be boiled down to Campus Fabric driven by DNA Center, okay? Automation and assurance from DNA Center. Simple as that. So instead of you, the human, going out and typing all the command lines, DNA Center will program all the appropriate configurations for you, and then again, that data will all get sucked back in, and I'll tell you about how the security elements work, okay? Pretty clear? Simple? Okay. So let's get into roles and responsibilities. So I also have like little subsections, again, just kind of mental notes to kind of help us, where are we in this big journey. So again, the first part is the really high level stuff. We're thinking about the car and what are basic concepts here. So who's curious what the word fabric means? You probably read it while I'm sitting here talking. At least 1, 2, 3. Okay, but don't be shy. We're here to learn. So, and I always tell a story here. I mean, you can read the text. I don't like reading text to people. So the term comes from a desire for full mesh, okay? Now, some folks are coming from a data center. One of the things I normally emphasize here is this is about the campus. This is about the user environment, right? If you think about buildings, even like this venue, things are geographically spread out, right? So why do we build hierarchical networks, right? And it's super expensive to run fiber across the street, right? And why do I put that little access switch out there and all that stuff, right? Now, on the other hand, if I had the money, it would probably cost me like $1 billion. I would have a perfect amount of fiber and connections, and all routers and switches would be equal. It would be the most amazing network ever, I promise, right? If you had $1 billion, right? So, unfortunately, the finance department says, that's not going to happen. But I still have that technical desire for them all to be equally connected with one another, right? Hence the term fabric. That's where it comes from, it's like cloth, right? logically, it appears as though they are all equally connected to one another, okay? Now we do that, right, as a logical topology. This is where I almost have to read to you. Now, even if you've never heard the term fabric or dealt with a fabric, you've probably dealt with some term like that. And who's built a GRE tunnel at least once in their life? Okay. Whether you knew it or not, you were building a fabric-like architecture. What you're doing is you're applying an additional packet, an IPv4 packet in this case, and it travels over the network, and all they see is that outside packet. They never actually see the inside. It gets to the other side, you take off that packet, it's back to the original, right? Ergo, it's a tunnel, okay? I mentioned wireless, right? So CapWAP. CapWAP is another excellent example. I can build a logical topology, bunch of CapWAP tunnels, and it is completely separate logically from the physical wired environment, okay? So that's effectively what we're doing. Now, the next most important piece, and again, I hate reading, but there's certain points I want to call out, alternate forwarding attributes. Now that sounds sexy. What I mean is I'm putting some extra goodness into that outside packet, something extra cool that I can do some stuff with, right? And when I talk about how does SD access give me extra security, it's these additional alternate attributes in the frame header that I'm going to use for security, okay? So now you know what a fabric is. You have a sense of an overlay, a logical topology, and an underlay, which is your physical topology, okay? Now this next slide just drives home the point. It's the same picture. The reason I end up showing two of them is I like to make a point about the underlay control plane. Now, another thing about this network is this probably is your existing network as it is right now, right? You've got OSPF, you've got EIGRP, some protocol, this could even be spanning tree, something defines how do I get from this edge device over to this edge device, right? And as far as the endpoint, the host knows, he's just plugging into some guy and the packet comes out the other side, right? He doesn't know that I'm physically plugged into a catalyst switch and I'm using spanning tree protocol. He doesn't care, right? So using that same logic, we say, okay, well, look, why don't I take another control plane, a different set of information, okay, and I'll build this logical overlay topology. And as far as the hosts are concerned, they don't know any different. They just know it comes in one side, comes out the other side, okay? And again, the point I'm trying to make here is there are two different control planes. This confuses people a lot, okay? So again, this is probably OSPF or any regular IGP, okay? But its job is to get the packet from this switch to this switch, okay? And there's some other stuff in the middle. Now, the way we accomplish this is encapsulation. I've already kind of made the whole point about the IPv4 GRE header and that kind of stuff, right? But it means literally putting some extra bytes in the front, and then I forward everything on those outside bytes, okay? And if you can memorize this particular picture, you've got it all figured out, okay? Which reminds me of another little line I usually give. All this technology already exists. So a lot of people come in here, they're like, oh my God, there's some new terminology I've heard. What the hell? I just learned everything and now it's all changed on me. All of this exists today, and the fundamentals are exactly what you know today, okay? We give it some fancy words, and what's different is how we're, combining it all together, okay? So again, you already know how networking works. You've already seen examples of overlays, okay? I'm just putting it together in a specific way and calling it SD Access Fabric, okay? All right, now, I got to build this underlay. There are, and I've said there are other fabrics out there. Many of the fabrics, in an attempt for consistency, which is a good thing, mandate you must use their underlay. In other words, you have no choice, and that network you've been building for the last 10, 15 years, rip it out, okay? And that works in a data center. That works maybe even in a service provider, because everything's in the same rack room. We'll just wipe the slate clean and we'll put in a whole bunch of new stuff, right? Now you go back to your campus environment where your users are, remember, and you've built this over 10 years or whatever, and you say, rip all that out and start over again. Who's going to rip out their network on Friday and come back on Monday? Good for you. I'll buy you a beer. So one of the key points of SD Access is we do actually support a manual underlay, as in you own it. You built it, right? It does mean the responsibility is on you, okay? Because guess what? Remember the previous picture. If the underlay's screwed up, the overlay's screwed up, okay? But having said that, it gives you that freedom and that flexibility, and it really is your network. So you've already been building it on OSPF or whatever. You know what your addressing scheme is, right? You know where your routers are. Just use that as your underlay now and put the overlay on top of it, okay? There are some key things to keep in mind. Remember I keep talking about that frame header? It adds additional bytes. Now this isn't a big deal in the LAN, right? I probably have high bandwidth Ethernet links. I can increase the MTU, no big deal. If you're trying to stretch this over a WAN, you're going to run into some problems, okay? There are sessions, gets into advanced sessions. I'm not trying to belabor the point. And particularly round-trip timers, this means more for wireless, and how does DNA Center talk to the switches? How long is the distance to get to that switch, okay? Those are the key ones. There's some other notes in there. It can technically be layer 2. We strongly recommend layer 3, mainly for stability. So if I go back to, I think it's only one click away, if my clicker wants to work. If I go back to the previous picture, this thing has to be stable, right? I want it to be as stable and as simple as possible. Another thing I always talk about is, or a point that I make, there's a bunch of hidden slides. So has anybody already gotten the slides? I've seen a few guys. Okay. I don't have enough time. I could spend hours and hours and hours talking about this. So there's a bunch of really cool hidden slides. People ask me what do the configs look like? And what about this? What about that? I put a whole bunch of what about that's in the hidden slides, okay? So I even make some extra points about the underlay in those hidden slides. Now where I was going was the why layer 3, right? And it's stability. It's as simple as that. I don't want to deal with spanning tree and layer 2 broadcasts in my underlay, okay? So if you do those things, you can 100% manage it. We'll just put fabric on top of it, okay? That's the good news. In other words, you keep using your network, slap in a couple of switches, you can have SD access. Awesome, okay? As opposed to rip and replace and start over, okay? Now, moving forward, right, I actually have a new building that's coming online, right? Brand new building, awesome. I don't want to do all that manual stuff I used to do in the old days. We do provide a fully automated LAN automation for you, okay? And it does all the IP addressing, it will set up the routing protocols. Awesome, out of the box, it uses plug and play. Who's familiar with plug and play conceptually? Okay, it's like it sounds, right? Plug it in, calls home, the switch above it becomes a DHCP server, gives him his IP, we set up the addressing, routing comes online, he becomes part of the fabric. Awesome, okay? That's the pro. The con, the only con really, is we're gonna do it the way we wanna do it. It's 100% prescriptive. You don't get a say-so about it, okay? But that's no different than any of the other automated solutions out there. And again, it's about consistency, okay? It's layer 3 routed. We use ISIS. I will explain in the hallway why we use ISIS, because this always comes up. In a coming release, we're actually going to support OSPF. So if I want to peer and basically you'd make this another area, and I can peer this OSPF area to another area, okay? But you get the point. The point I'm trying to make is you can do manual and you can do automated. And it's not like either or. It can be some over here and some over there, okay? Now, getting on to roles and terminology. So same picture you saw before, and those 3 principles that I keep talking about, right? So something somewhere does the automation, and then something does the assurance, the data management piece of it, machine learning, machine reasoning. So that's all done by DNA Center itself, okay? When we get to the controller section, and like I said, I'm trying to save time for a demo, you'll actually see some of these elements, right? But it's a brave new world. It's a graphical user interface, clickety clickety, and it just comes online, okay? Now, at the same time, we do use the Cisco Identity Services Engine, which some of the folks I was talking with got to see yesterday, for as it suggests, identity services. Remember I said identity-based policy and segmentation, and the policy itself. So what's pushing the actual policy down to the switches and routers? It's ICE, okay? But those working together forms the controller aspect of SD-Access, okay? Now within the fabric, and this, I'm gonna have deeper slides on each one of these. We're gonna go deeper and deeper in the rabbit hole, okay? But high level, the control plane. Just like it sounds, it is the brain of the system, okay? It is probably the most important box in the entire solution. If this box is screwed up, then guess what? I don't know where anything's at, okay? Now the most common example I give, and I'll probably reiterate this when I get into that part, it's like a route reflector. Who here does BGP? Maybe that example doesn't work for a lot of people. A fair amount of you. Okay, but you get the point. I could fully mesh BGP to all my routers, but that's a waste of resources, and they don't really need to know about all the routes, right? As opposed to one guy does know where everything is, and then they all just kind of check back in with him. Similar concept, okay? All right. Now, like I said, I would love for everybody to just go home on Friday, rip out your network, turn on SDA, and it'll be amazing. I'll make $1 million. You can have good luck. So you're probably going to end up connecting this to your traditional network, your existing network, somewhere, right? And just like the name suggests, that's the job of the border, okay? In simple terms, he speaks two languages. He speaks SD-Access Fabric on one side, and then he speaks traditional IP routing on the other side, okay? Now, from a consideration perspective, that means he needs to be powerful enough, and he has to maintain two sets of routes, and he has to be, sufficiently sized to support these two different roles, okay? So he's probably the second most important in this relationship. Last, but definitely not least, on the switching side is the edge nodes, okay? Now, like I said, these are all, intentionally simplified names, right? We don't want to overcomplicate the names. But just like it sounds, that's the edge of the network. It's the outer perimeter, and that's what connects to the host, okay? And we'll talk more about the kind of things they have to do, but you get the point. If I plug into a host, that's an edge node. Now, the other point that I made, this is what I was worried about, was clicking, remember I said my first point was an integration of automation for the wired and the wireless, okay? So we have this sense of a fabric wireless LAN controller and fabric-enabled access points, okay? There's a whole session on wireless. I don't spend a ton of time on wireless, but I do have at least a couple of slides on wireless to talk about it. And then the last one, which isn't really a thing, but I'll sometimes say intermediate node, or you'll hear the other teams throughout the week say intermediate. You remember, it's a tunnel. It's a virtual overlay, right? And I'm just passing this packet along the way. Those people in the middle, all they see is an IP address. That's all they see. Okay, so if I say intermediate node, that's what I mean. Some normal IP device in the middle. And I always like to spend a little extra time on this one because, again, this is your existing network. You're always like, well, I bought that Juniper box, and they do IP, I promise. Or I have some HP switches, whatever. It's fine. They can be underlay IP forwarders. They're just not actively participating in the fabric, right? They're part of the underlay, okay? All right. This clicker. Anybody need some fresh batteries or something? Okay, so now we're getting on to the individual elements themselves. And it's kind of repetitive, but again, we're going deeper and deeper into the rabbit hole, right? So you already have a sense of what the control plane is. It's the brain of the system, right? In the end, it's just a big database, right? There's nothing super complicated about this. When we talk about the actual technology, when we get into fabric fundamentals, I'll give it an actual technological name. But it's as simple as a mapping of the endpoint ID to a current location, okay? That's the part I want to drive home. The most common example I give are smartphones, mobile phones, and cellular traffic. Now, it's not exactly the same, but you get the concept that I have a specific phone number, I have a specific SIM, right? And it's not like when I move to another city, I have to get a different phone number or a different SIM, right? The cellular network, on the other hand, is currently mapping my SIM to the closest cellular tower. Make sense, right? If I'm on the phone and I move to a different one, it just maps me now to the next cell tower, okay? Same thing's happening here. That as I'm using my tablets or my phones or my laptops, my cameras, roaming, right? I mentioned wireless, right? I just need to know which switch you're currently connected to. If you move around, I just update your location, okay? And that's the job of the control plane node. Keep track of the location, okay? So, now I didn't make a point about a specific address either, okay? Up until this Cisco Live, we had only supported IPv4 addresses and MAC addresses. So I'm happy to announce, for those that care, we've now added IPv6 endpoint addresses to SD-Access. So I don't know if that makes anybody happy, but like I said, that's a big one for us. But in the end, again, it's like the phone number, right? It's a unique number that signifies this host, right? And all I gotta do is map that number to his location, okay? Now, the flip side of that is that the individual edge nodes, which will be my next part that I go into, when that host first connects in, he says, hey boss, Sean's laptop is currently connected to me. Okay, cool. And if anybody wants to talk to Sean's laptop, he's currently connected to, you know, switch number 1, something like that, okay? All right. My animation's being weird. There it is. Wow, okay. Never mind my terrible PowerPoint skills. I'm just simply showing you that, look, IP address 1234 is currently anchored on fabric edge number 1. Right? It's just a visual example of what I was describing. And I can do that with MAC addresses. I have a whole nother part where I'll talk about address resolution and how I can do ARP and those kind of things, okay? But you get the main point. Any questions? I mean, I'm kind of chugging along. Everybody's still awake, and so far so good? Okay? All right. Now, the way this works, I mean, you can see what it is, but I try to show the platforms of each type. So the reason I'm making this point is people get confused. This is about the fabric control plane. So which devices can be a control plane? And then I repeat myself later. You'll see the same switches, but now I'm talking about edge nodes, right? And so on, okay? I also try to use the colors to kind of make it different. So I already had people who raised their hand for Cat9K. This should be exciting to you. The one that's new is the Catalyst 9600. Okay, this is our modular distribution and core switch. The way the slide is set up is kind of a small, medium, large. Make sense, right? The reason I make this point is, remember the control plane node's got to keep track of all these entries, right? So translate that into technical terms, it's like his fib TCAM size, okay? And if I have a small location, a small fabric, I can use a small box. It's perfectly fine, right? On the other hand, if I have a massive fabric, I need to get one of the big boxes, okay? That's all the point. Now, in addition to the Cat9K, which was built for SD-Access, we actually support almost all of the switching and routing portfolio, okay? So in addition to that, we support the Catalyst 3650, 3850, the 6500 and 6800, the ISR 4K, that's all of the 44s, 43s, 42s, and the ASR 1Ks, particularly the X and HX series, okay? So moving on from there, let's look at the edge nodes. Ah, you got me new batteries, thank you. All right, I'll just do it while I'm talking. Thank you so much. So, like I've been saying, the edge node is what gets connected into. So, the line says first hop services. So it means a lot of things, actually. The first, if I have this identity-based network, right, then the very first thing I better do is have some kind of identity. Now, this can be a lot of things. It can be as cool and sexy as 802.1x, right? It can be MAC address bypass, central web auth. It can be all the way down to, like we do with, switch port mode access. Port 12 is a part of this IP pool. It's a static mapping. But at least now the system has a sense of the identity on that port. I know Sean's laptop is currently plugged in, okay? Now, once I do that, like I said, he'll call home and say, hey, boss, Sean's laptop is currently plugged into switch number 1. Cool. Control plane adds him to the database. And then the next thing, unfortunately, we invented this thing called IP a few years ago. And so our laptops think they need to talk IP, right? And they need to talk to some kind of default gateway kind of thing, right? Now, you remember I was making the point in the underlay about why we want the underlay to be layer 3 routed access? Because now what's going to happen, you used to have your SVIs, your VLAN interfaces, on your distribution layer. You probably run HSRP or VRRP, something like that. Now that access layer switch is your first hop gateway. He is actually the SVI and the owner of that IP address, okay? And we'll talk more about that in just a bit. And then remember, it's an overlay, it's a fabric. Now this is a subtle point, but it's a super important point, right? Because the question always comes, you know, do you support SD access on this device? And my answer to them becomes, well, do I support the encapsulation or not, right? If the ASIC can support the encapsulation, the answer is yes. If it cannot support that encapsulation, the answer is no. Simple as that, okay? All right. Now, remember, different color, similar switches. Now we're talking about edge nodes, okay? The other one that's new in this picture is the new Catalyst 9200. This also uses the same ASIC as the other Catalyst series, the UADP, but it's a much, much smaller version of it. So same logic, and that's why it's not one of the control plane nodes. But it's you know, a wonderful, low-cost, entry-level access layer switch that can be used with SD access, okay? The other thing that's interesting to be said about this is, you know, these big honking 100 gigabit Ethernet fiber switches, and you say, well, when the hell am I ever going to connect a device into that, right? Does anybody have like a local server farm, services block? They need to connect that one server into their campus? Yeah? Okay, that's why. Because he becomes an edge for that server. Okay? His question is, can it be an edge and a control plane at the same time? Absolutely. And if you do go visit some of the extra sessions, they'll be talking about different combinations that you can mix together. Yeah. And whenever I describe that, I always describe it as like turning on an extra feature in OSPF or BGP or something, you know. It's still the same protocol. I'm just adding some additional functionality to it. So, you know, and then the extension of that is, yes, he's doing more CPU, he's doing some extra work, but the short answer is yes. It can be multiple roles at the same time. Okay, same thing I said before. Now for the edge node, right? You have an existing network. You probably have 3850s, 3650s. You might have a 4500. The one I want you to pay attention to is this one. Anybody using 4500s today? Still as their access layer? Quite a few of you. Okay, who has SOUP 7s? Same people. Okay, you need to move to SOUP 8. Okay, and the answer is what I described, that we put a special FPGA onto the SOUP 8, particularly the uplink ports, because you know he's the access connecting up, that can do the encapsulation, and SOUP 7 does not. Now, who has 4500Xs? They are based on SOUP 7E, so they do not have this FPGA. So the answer is no. Okay, and you can guess. I hear this question all the time. But having said that, they can still be that intermediate underlay device, right? So a lot of people, particularly 4500X, it's a great 10 gigabit distribution layer switch. So you just let him be the underlay, and you just put some other switches on the other side of him. Okay, on to border node. So we talked about it. You know, he speaks 2 different languages. You get the basic idea. It's the border from one area to another, right? Entrance and exit. Now, there are actually 3 different types of border, just to make it complicated for you, right? But it's specific jobs that they have to do. One question I meant to ask in the beginning, I did not. Who is already running SD access? onesies, twosies, okay. So for you guys, which is cool, we had made them into distinct roles, and we talk about them a lot. In fact, as you go through the course of the week, people will still use these terms. So the reason I decided to leave them in the slides is because they still exist for 1.2, okay? Now I know it's tough in the back. This is a screenshot, and what I'm trying to show is right here, and you had to like distinctly make it one type or another type. Okay, and it was just that type, or it was the next type, or whatever, right? Now, starting with the first one, internal border. Just like it sounds, these are for routes that are inside my company. And more importantly, I want those routes. I'll talk about each one of these in turn, but it's like it sounds. Internal to my company, I want those routes, right? External to my company, okay? Think of this as like your default route, right? I just am going to throw it over there, and he'll figure it out, kind of thing, okay? So it's the border to the internet, for example, right? And then we cooked up, again, to make it even more complicated for you, we cooked up a third case, okay? And we gave it a really bizarre name, which has confused the hell out of people, called the anywhere border, okay? And it's really just in one portion internal border and another portion external border, okay? Now, and I'll go through and explain that. So in an internal border, like I said, I want those routes. So just like an edge node would tell the control plane node, you know, hey boss, Sean's laptop's connected to me. Everybody got that, right? Same thing now for a border. Now imagine there's some routes like a data center. I want my fabric to know about those data center routes. So he's going to actively import those routes and register them with the control plane, just like the edge node does. So he's just like an edge in that case, okay? But the external border, like I said, doesn't care about any of that. He's not going to import anything. It's a default route. I don't know what else to do with it. Throw it to him, okay? Now the anywhere border. Now the anywhere is a bit of both, okay? So maybe I have some routes from the data center I do want to import, but other than those few routes, everything else is default. That's all it means, okay? Does that make sense, like the combination of the two? Just these 2 or 3 routes I want to come in, and I'm going to create a route map that filters everything out, and then everything else I don't care about. I'm just going to throw it at him, right? So in that way, just to confuse you guys, okay? And we said, look, it's really confusing to people. It's really nonsense. So starting with 1.3, this is why I asked, you know, who actually has 1.2. For everybody else, you're just going to get the new way. So lucky you, okay? Now it's just, again, the border, okay? And the border has a couple of few options I want to turn on or I don't turn on, okay? Its default state is an internal border, so I will try to import everything if I don't click on anything. And then what we've added, again, I know it's hard for the back, but there's some extra little checkboxes and say, look, you know, I just want it to behave as though it's an external border, right? So let me tick this box. And furthermore, I don't even want to import any routes. Right, so those are the functional equivalent of what we used to call internal, external, and anywhere, okay? But now it's just the border, it's just one little tick box, yeah. This question is, can you connect directly to the ACI network, or do you need an NNI to do so? So, directly as in fully integrated and there's a native handoff between the two, the answer is no today. We are introducing that for SD-WAN sooner than later, and we already have plans to do so with ACI. If you do a connection today, and there's a whole section, I was telling this guy's also looking at ACI, there's a whole section just on integrating with external domains, so that's the session I want you to go to. Short answer is it's an IP-based handoff. It's a VRF Lite handoff specifically. So I'll set up a sub interface. It'll have, if you don't know what VRF Lite is, it's a VLAN trunk. And I use the VLAN IDs on the trunk or sub-interfaces to keep them separated. And then I have the different VRFs, and I give that off to the ACI in a shared L3 out, basically. Okay. Yeah. The equivalent on the other side is the shared L3 out. Okay, but you get the point. Now it's just one border again, and there's these options. You know, I can choose whether I want to import the routes or not import the routes. So we've simplified it, okay? Onto the platforms. See the usual suspects. Again, different colors. I'm talking about the border now. No surprise, the Cat9K does all these roles, so that's what I always make a point of. Like, if you need to reuse your existing switches, you can do that, right? You'll probably have to upgrade your software, change some config, or if you're getting that new environment, you can just get some Cat9Ks and be guaranteed that it's supported. Okay, so with the legacy ones, who wants to mention the new player on this slide? 7Ks. Okay, so particularly for the border, and particularly because a lot of people have Nexus 7Ks. Who has Nexus 7000? Particularly 7700s. Same people? A lot of your hands went down. Okay. So I mean explicitly 7700s, and I explicitly mean SOUP 2E with M3 line cards. Okay? And better yet, whenever a marketing person shows you an asterisk, you need to start looking around the slide or raise your hand, okay? Say, what the hell does that asterisk mean? So it's kind of tiny, but it says external border only, okay? In other words, that default border that doesn't actively import routes, okay? But a lot of people, and there's no official term for this, but we've unofficially started calling them kind of their job. So there's like data center borders, there's a WAN border, maybe there's my little wireless area border, something like that. So even similar to the ACI question, this is going to my traditional Nexus 7K data center, right? And it's going to be that same kind of thing, just an IP handoff with VRF Lite, and I'm just going to throw routes at him, throw the traffic at him.
That has the MPLS license as well.
So his question was, does that also require the MPLS license? It used to. So I forget the exact version, 8.3, they've lifted that requirement. You do not, if you get to the right software version, you no longer need the MPLS license to do this. But prior to that, you did. Yes? What about Nexus 9K? They can be an underlay switch, and DNA Center does actually manage them as an underlay, but they do not participate in the fabric. Yeah. Okay, so let's look a little bit deeper at each one. Like I said, you already kind of get it. This is just going deeper. And I said the most important thing, the only part I want you to memorize is this line. It imports and registers the routes. So I have that data center route. Maybe it's a /16 or something, right? And I'll take that route and I'll send it to the control plane node. And so when a host says I need to get to that data center, he says, hey boss, where the hell is this /16? He says, it's on border number 2. Cool, just like an edge node, right? So now I can send it directly to border number 2, and it goes on its way, okay? And that's the goal you're shooting for, okay? The part I skipped over is we have to export the routes too. I need to tell the data center about my host route so he knows how to get back, right? And that's true for all borders. Similarly, this last one, if I leave the fabric, then I have to do it in a traditional language, right? So it's going to be your standard VRF. We just talked about VRF Lite, route targets, route distinguishers. If you've done VRF routing, you know exactly what I'm talking about, okay? Now, the external border. The difference on this one is it does not import anything, okay? And again, I've made this example several times. I think you get it now. It's literally the end of the list. So what's important here is actually the bottom part, if no entry is available. So I go to my list, I say, where is this DC route? Where is this DC route? Where is this DC route? I don't know. Go ask that guy, right? Now that guy has BGP on the outside. So the BGP routing protocol does know where the DC route is. It then sends it on to the data center. But it has nothing to do with the fabric making an intelligent decision about that, okay? Pretty clear? So far, so good? Everybody still awake? All right. Starting to see some nodders. And it's early. I get it. Man, I haven't even had my coffee. I ran and just grabbed a coffee as I was running, and I haven't had much time. So I talked about wireless. Okay, again, there's an entire wireless session, and I encourage you to go to it. If who consider themselves like a wireless person? Good, okay. So my point is, like, that's important to you. I encourage you to go to that one, particularly EWN 2020, okay? They're gonna give you the full 2-hour version of Fabric Wireless. I'm not giving you the full 2 hours, I'm giving you the 5-minute version. So, when you do traditional wireless, it uses CapWAP, okay? It uses CapWAP both for AP management, and it uses CapWAP for client data, okay? Now, controlling APs really isn't that hard. Very lightweight, you know, it's really just setting up the radios, upload some software, some config, easy, easy peasy. The real burden comes from the client data, okay? You know, and the wireless standards are getting bigger and bigger and bigger, right? So I'm sucking in now hundreds of megabits, right, up to gigabits of data, putting it into a CapWAP tunnel, shipping it over the top of my wired network to this gargantuan wireless LAN controller, and then it finally comes out of the network, meaning I have to put security, I have to put quality of service, everything lives over there. And that's different than all my cameras and my printers and whatever wired devices I have here, okay? So, what makes Fabric Wireless different? Now, in the little legend, I've used green and blue to talk about the control CapWAP and the data CapWAP, okay? Now, one of the reasons people love wireless, and particularly a centralized model, is that centralized AP management. So we've kept that. That is still true, right? AP comes online, calls home to the wireless LAN controller, we bring them up, and so on, right? When you get into the actual SSIDs and the client IP, you know, what we used to call a VLAN, that now is dumped off in a single hop tunnel. Come on. Wait for my clicker to catch up. There it is. So the part, it's hard to see, but the part I want you to pay attention to is that little tiny one-hop tunnel, okay? As opposed to carrying that all the way home to the wireless LAN controller, right? So the tunnel actually terminates on the first hop switch. Therefore, I go from 802.11, get over the wire, come here, strip it off, it becomes regular Ethernet again, right? So in simple technical terms, that's how I give you a single unified security and QoS. And more importantly, I've distributed the data. Instead of backhauling all that data to this gargantuan wireless LAN controller, now the client data immediately is dropped off on the access layer switches. So I distribute it out like that. That's the reason you want it. Question?
And those two modes are not mutually exclusive of one another. You can have multiple SSIDs that could be over the top, and then some that are just Fabric enabled, right?
Right. His question is, can you have a mixed mode of some SSIDs are Fabric enabled and some SSIDs are not? That's true. There's a bunch of elaborate, this is again is the longer version. There's a bunch of elaborate different mixed models and has some weird roaming implications. But strictly speaking, yes, I can have simultaneously SSIDs that are non-Fabric over the top, and I can have Fabric-enabled SSIDs, right? Particularly for like migration, right? So I want to keep using the way it is today, don't touch it. Let me turn on a couple of new SSIDs that are SDA Fabric. Has anybody been in and around the Marriott Hotel? A couple few of you. Anybody of those people, you've been on wireless? Guess what the wireless is? It's SD access. These ones are not. So that's a good mixed mode question. There's always layer 8 involved, too. I can't solve layer 8, I'm sorry. Yes, question. Behaviorally, yes. His question is this like FlexConnect? Behaviorally, it's like FlexConnect, but it is independent and a separate thing. And you cannot use FlexConnect with SD Access Wireless because they behave very similar. So it's like one or the other. If you use FlexConnect, it would be in a traditional centralized mode. This is local mode. But again, there's a whole wireless section. I encourage you to go to that. I don't want to beat this one to death. I just wanted to drive home the key points. The last one, which is again kind of subtle. The wireless LAN controller is still keeping track of the client MAC addresses. He is responsible for roaming, as it were. But what he's doing is he's sharing that client information directly with the Fabric control plane, right? So now I have a sense not only where the access point is located, but even the client that's connected to the access point and his location. So in that way, the Fabric control plane is also handling roaming, layer 2 roaming and layer 3 roaming, okay? Subtle things, like where a little dotted line is like a super important point, you know? Sometimes they don't explain what the little dotted line means. Now, I don't have a lot on this one, mainly because of time, but again, there is a session dedicated to this. So we introduced this new concept of fabric extension, or SD-access extension, and it's really about like industrial Ethernet, compact switching, and these things. You can see, you can guess based on the picture. And the reason we call it extension is they're not actually participating in the fabric, as in they don't do fabric encapsulation, and they're not actually doing the security enforcement, okay? What you're getting out of this is really the automation piece and the stitching everything together, right? So what the DNA Center does is it just natively will configure the link going south with the appropriate trunk and VLAN, and it will stitch together all the IP pools to have it operate, okay? Therefore, we've extended the fabric, okay? So it's an interesting concept. If you need that, you know, long-run industrial manufacturing kind of environment that uses a lot of IE switches, I can have all of this managed by DNA Center, okay? But the point there is that the edge nodes do all the work, okay? Question? So his question is, not everybody uses these particular switches, and you know, maybe I have these other third-party switches. There's a technical answer and an official answer to all these questions. The official answer is no.
I think his question is more about other IoT things that are not connected to an IE2000. So your door sensors, your building sensors, traditional, non.
But if it's not connected to this, it would be connected to the edge node. Maybe I don't understand the question. It can do both. Yeah. So if you're talking about the actual endpoint itself, then yes, you can connect either to the edge node directly or you can connect to the extended node. Cost. It's really cost. So his question, I'll repeat the question. He's asking, like, what does this really buy me? It's really about the expense of it, right? These are much cheaper than Catalyst 9K switches. Okay, I don't know how else to describe that. Having said that, they're cheaper because they don't do as much, right? So you still need the edge node. Now it's kind of like the distribution layer to have that functionality, right? But I can save some money. And there's like I said, this is a whole long story all by itself, just like the wireless thing, so I don't want to go too deep. But a lot of people use smaller switches just for extension. That's where the term comes from, right? So I can buy a bunch of Cat 9K switches, but then I can hang a whole host of these little tiny switches off of them, right? So I just save money that way. No. Yeah, he was asking about other models. I would encourage you to go to the IoT, the SD-access extension session as well. But the short answer is no. Okay. And we're only still in the fabric fundamentals. I told you this would be the long one, but like we're almost at the halfway point, so I really want to get it going for you guys. Okay. So now you know what a control plane is. You know what a border is. You know what an edge node is. You've been introduced to fabric wireless and just now to fabric extension. So you have a pretty good concept of all the main pieces that build up a fabric, okay? So now we're talking about the actual like components that I can use to do some stuff with. And this is where the security really kicks in. Talked about that identity-based security and segmentation. So first and foremost is a virtual network, okay? Now this is just a fancy name that we've renamed for a virtual routing and forwarding instance, okay? Who knows what a VRF is? Does anybody not know what a VRF is? And don't be shy, I'm asking because I want to answer the question or not. Okay. So what it means in traditional routing sense is an isolated routing table, okay? And the reason that's important is if they're part of the same table, then there's a potential that I can get your route and I can attack you, right? As a hacker kind of thing. If they're in separated routing tables, I can never even see them, right? The example I usually give is like a phone book. You know, I can have a phone book for San Jose and I can have a phone book for San Diego. They're both phone books. It's got a listing of phone numbers and all, right? But if I try to find you in the San Jose phone book, you're not there because you're listed off in the San Diego phone book, right? That's a VRF, okay? And again, we just changed the names. We're trying to simplify it so you don't have to like go get a CCIE to build our solution, right? But in the end, in technical terms, it's a VRF, okay? So that's what this picture is showing. I have one VRF that's called campus, another VRF called IoT, and another VRF called guest, okay? Now, what they do, and the real value of the part I want you to memorize is I kept saying that fabric header had that extra forwarding attributes, and that was where the magic was, right? So what it means is I'm going to put the VRF ID directly into the fabric header. Gets carried over the overlay, pops out the other side. I can put you in the correct routing table, okay? But if I don't have that VRF ID, then I need some other kind of tool. Mentioned VRF Lite. Who here does MPLS? Okay, so you get it. That's just a tool with the MPLS label to carry the VPN ID, okay? But I don't need MPLS to do this now, okay? That's the part I want you to memorize. And then I mentioned this when I talked about the border. If I need to talk north of the border, it's a VRF. So I need to talk VRFs to someone else. So if I need to integrate SD-Access with MPLS, it's going to have a regular VRF definition. I'll share routing targets and so on, okay? Again, if you know what route targets are, you know what I'm talking about. Scalable groups. Okay, so the other marketing terms you'll hear are macro segmentation, which was the previous one. Macro is in very big, right? And micro segmentation, as in very small. So within a virtual network, now I can create these smaller little groups, okay? And just like, the part I want you to memorize, just like the VN, I carry this scalable group tag around in that frame header, right? So now I not only know that, hey, you're part of campus or you're part of IoT, right? You're in campus and you're part of the HR department, right? Or you're part of the engineering department, right? Okay? Now, when you talk about virtual networks, and I have a section on policy, so we'll come back to this a little more later. But in simple terms, just by having them in different VRF tables, they're secure from each other. I gave the whole phone book example. In this case, they're inside the same VRF, so they can talk to each other by nature, right? If you don't do anything, they can just talk, right? So the most common example here is access control lists, right? So instead of an IP-based access list, I will just have a tag-based access list, and I just use this tag instead of some obscure, 32-bit IP address. Yeah, question in the back. Does this require an ICE? Yes, it does. Absolutely. Then you will be using only the automated and host mobility portion of it. So it's not required for you to get onto this stage. You just won't gain any value from it. That's usually what I tell people. Like, I'll get all the values of like the host mobility and the control plane, the fabric, all that good stuff, plus the automation from DNAC. I just won't, at that time, in that stage, gain any value of the group-based access control. But you'll still get the VRFs, yeah. Does that make sense? Okay. Yeah, question? Next. Yes. I usually give this joke. His question is the term security group tag? And it's also kind of like I introduce the concept before I introduce its actual name. Who's heard security group tag before? Oh, quite a few of you. Okay, cool. So it is not a security group tag. It is not a scalable group tag. It is a source group tag, okay? Now, both security and scalable are entirely made-up marketing terms, okay? It is, and this is what I was saying, I actually will cover this more when I get to that part. It is a 16-bit identifier. It's a number, okay? And I can use it for whatever the heck I want to use it for, okay? The first people to use it were the security team. So hence the term SGT became security group tag. Then we said, wait a minute, I can do quality of service, and I can do PBR. I can do all kinds of cool things with this tag. Hence the new name, scalable group tag. But if you want to get really technical, it's actually neither of those. So you can call it a security group tag if you want. People will get it, but the new name is scalable group tag. It's just a term. Yeah, there was another question? Same question? Okay, perfect. 2 for 1. Okay, like I said, the thing I want you to remember is I'm using this tag to perform my microsegmentation, and I carry the tag around with me across the fabric, okay? Once I have that tag, then I can build these group-based access control list, okay? And again, to my 3 main values, this is really where that value kicks in, okay? Now, I mentioned that unfortunately hosts use IP addresses. I can't control that. So I have to give them this notion of an IP information. Now, one thing I've not said, and I've tried really, really hard not to say, is any notion of a VLAN, okay? A virtual local area network, right? Now, the reason for that is intentional. Just like we've changed all the other names, we intentionally have not said VLAN, because why do we build VLANs? Like, who loves spanning tree? They love spanning tree? Yes. Who loves outages? Who loves layer 2 flooding? Who has spanned their VLANs across their core to serve one purpose? Yes, okay. I'm surprised that so few of you said yes. Or you're just kind of shy about this one. Yes. So it's not that we love VLANs or we love spanning tree or any of that. It's that my users, your users, have a specific application that requires layer 2 connectivity. And the only way I can solve that problem is to stretch layer 2 over the top, right? What a mess, okay? Now, I also said earlier, you guys know these things. You know the technologies. You understand what's happening here. So even if I use a fancy term like host pool, it means on the edge node, I'm turning on a VLAN, I'm configuring a VLAN interface, an SVI. Then on that SVI, I'm turning on an IP address, a router MAC, et cetera, okay? The part I mentioned earlier is this is happening on the edge node, okay? And then north of that, I'm going to do this dynamic location mapping, right? So as far as my client is concerned, I'm connected to the switch, and then the switch will map that host-specific. So the most interesting thing about this is host-specific entries. So this exact /32, or if it's a v6 address, /38, okay? And I'll come back to that point in just a moment. Now, picking up from there, Anycast gateway. So who's heard the term Anycast before? Quite a few of you. Okay. Just like it sounds, it's one address spread across multiple devices. So anyone speaking to that address thinks they're just talking to one thing, when in fact it might live on a whole bunch of them, right? And whoever happens to be closest is the one that answers, right? Now apply that to this gateway, right? So when I said that the VLAN and the SVI gets programmed on the edge node, what we're doing is the exact same IP address and exact same MAC address on every edge node, okay? So as I'm moving around, I'm on my laptop on a WebEx call, you know, I'll connect to a different access point that's connected to a different access switch. It doesn't even know that I flipped at all, okay? Because he's still talking to the same router MAC, he's talking to the same router IP, okay? I've preempted all the words. So hopefully you've dealt with HSRP, VRRP, same concept, okay? But the important thing is it's on every single edge node, right? And the value to me, little smiley face, is then the client doesn't have to know anything. I don't have to manage a bunch of funky different VLAN interfaces across my 200 access switches, okay? That's the value to you. Now, the concept of a stretched subnet. So like I said, everybody loves VLANs. They love putting them across their core because that's really healthy for the core of your network. But I have a specific need. My customer, my users need that, right? So when you talk about stretching a subnet, because remember we're doing this dynamic mapping, right? So now I've got this Anycast gateway on the edges, in that sense, and meaning that that VLAN and that IP subnet is now present on every single edge node, okay? And then north of that, I'm doing this location mapping stuff, right? So from the perspective of the host, it doesn't matter if I'm on switch 1 or I'm on switch 100. He's always connecting to the same IP subnet. And if I'm talking to someone in the same subnet, right, then it's just IP from my address to your address. It doesn't matter that we're separated by so many physical devices, right? The only way to accomplish that before was to create a layer 2 VLAN that stretched across those. So you pretend that you're in the same local area network, okay? So I'm giving you the same thing without all the penalty of that, and hence the term stretched subnet, okay? Will that still allow for broadcast? This particular example is no. Unless you turn it on. Now, what we also offer is a pure layer 2 overlay, okay, for devices that need broadcast and link local multicast, okay, which includes IPv6 neighbor discovery. I always get that question. So this is very similar. Anybody used VPLS? Like I put that example up there, but it doesn't seem to hit well enough. How about OTV? That gets more hands. Okay, you get the point. It's a layer 3 overlay. I create a tunnel, pretends to be layer 2. Okay, same concept, right? VPLS is for my MPLS people. It's virtual private LAN services, point to multi-point overlay. So now the secret is this second bullet. What we do in the underlay is create a multicast group of which all the edge nodes are connected to, okay? Who knows PIM? That's always a toughie, like fair amount, okay. So conceptually, and I'm explaining it because only half the room raised their hands, but I think everybody knows conceptually what multicast is about. You have to say, hey, I want to get that multicast stream. It's solicitation based, like please give it to me, please, please. And everybody asks, right? And then what it does is anybody that asks, they'll ship it out, okay? Since I already kind of know who all my edge nodes are, everybody just asks and they become a part of this underlay multicast group, right? In other words, they will all receive the same traffic simultaneously, okay? But its purpose is to facilitate the overlay broadcast. So the client sends in a broadcast frame. He will just translate that and encapsulate it into this underlay multicast group, which gets flooded to all the other edge nodes. They take off that multicast group, and it's back to the original L2 frame. Hence, I give you layer 2 in the overlay, okay? That's just an extra point. The last one is the other part I want you to remember, and it was even kind of like his point. This is not an all or nothing kind of deal. I didn't just expose you back to a bunch of garbage, right? You can do this on a per IP pool basis, right? So in other words, most devices actually can talk IP. So 80–90% of your pools will be just regular stretch subnets, right? But I have that super important building management badge reader that only speaks broadcast. So I create a badge reader IP pool, and I put those badge readers in there, and then I turn on flooding for that specific pool.
I got a question.
Yeah, question.
You ran into this. You can actually do that by port. So if you intermingle those two devices, you can turn that on. It's a configuration you put on the port itself.
The front panel port?
Yes.
Correct. When you assign the front panel port to that pool. Yep. That's right. And you can... That's right. That's right. Okay. Looking at the clock, I want to save some time for you. But you made it through the first part. So, and things will speed up a little bit now. So everybody now understands control planes, borders, edges. They know what VNs are. They know what pools are. They know what scalable groups are. Now let's actually talk about the technology. And then this was always tricky for me. Like, do I talk about the technology first and then the concepts? But it's hard to describe the concepts without actually using the technology to describe it. And I will say that we as Cisco are trying not to talk about the technology. Now, it's a weird thing to say, but it's like the VLAN example that I gave you guys, right? sure, if I know what it is, it's fine and it helps to the conversation. But what about the guy that's brand new, he just got out of college, doesn't know a lot about networking, but he really wants to turn on this network, right? So we're trying to get it to a point where I just need to know how to drive the car, right? I don't need to know how to fix the car. I shouldn't have to go get a CCIE just to turn on my network, right? So anyway, you get the point. We have been discouraged, actually, from talking about technologies to express the value of automation and assurance. Now, where I was going with that is this is one of the few sessions that you'll find where we explicitly call out the technology, okay? That's where the under the hood came from. This is not an extensive training on any of these topics. And finally, the thing I told you earlier, this is based on existing technologies, okay? That the difference is how I'm packaging them together to make something special, okay? But you can Google right now all three of these terms, and you will find a wealth of information on Google about these, okay? So, power of three, and you remember when we talked about the difference of the control plane, that's about messaging, right? And the data plane means encapsulation. And then lastly, the notion of security and policy, right? So the control plane is based on Location Identity Separation Protocol. It's one of the best acronyms there are that actually means what it says. Its whole job is what we've been talking about. Make a map system, keep track of where the IP address, the identity, is currently located. Simple as that, okay? I'm gonna have slides for each one of these. Then the encapsulation is based on VXLAN, okay? All my ACI people, anybody doing like BGP, EVPN? A couple onesies, twosies, okay. So VXLAN, conceptually, you've heard this, okay? Last one was back to the security group tags. Cisco TrustSec, okay? And this is where the SGT originally came from, okay? But all those things exist. You can check on them right now. The thing I like to call out here is this key differences. The value on this particular slide is the key differences. Now, I've said multiple times there are other fabrics out there. I mentioned OTV. It's another overlay, for example. But it is a layer 2 only overlay, okay? Similarly, MPLS, multi-protocol label switching. People think about it for routing, and it's weird kind of have routing with switching on top of it, but that was the reason it was invented, right? So those sorts of examples, right? But one of the things we said from the start, which is even the whole point about, well, I do have that app that needs flooding, right? We wanted to give you L2 and L3 from the start, okay? V4, V6, you name it, right? We talked about the host mobility, right? That's one of the key tenets, being able to move around, integration of wired and wireless, right? We talked about adding the magic into the encapsulation, right? One of the things, I didn't drive it home, I tend to drive it home later, is because it's an overlay, I don't need to change the box in the middle, right? A lot of technology, if I want to implement MPLS, guess what you have to do? You have to buy some very powerful LSRs, and you need to build a hop-by-hop MPLS environment, right? If you do it this way, I can leave that HP switch in the middle, and he's just forwarding IP address, and he doesn't need to know about VRFs or SGTs or any of that stuff, right? Only the outer devices need to understand the VRFs and SGTs. So that's why it's valuable to you. The other ones have more to do with what I was talking about, with the manual underlay, and a lot of fabrics out there force you to build their fabric the way they want to do it. Spine leaf. Sorry. Something in my throat. So you get the point. I can build a campus environment for all kinds of crazy reasons. Sometimes it's a hierarchy. Sometimes it's a ring. If I can give end-to-end IP connectivity, I can build an SDA fabric on top of it, okay? All right, moving on to the WILISP. So there are lots of protocols we could have chosen, right? And I can tell you why those are great in their own way, right? Traditional routing protocols, their objective is to each device have a view of the entire network. So they can themselves choose the best path, shortest path, for example, right? So that's like, I want everybody in this room to give me your home address and your phone number, right? And I will probably never talk to any of you, right? Or maybe I'll talk to 1 and 2, but I need everybody's phone number just in case I need to talk to you sometime, right? That's traditional routing. Now worse, if you change addresses, let's say you move homes, I need your new address as well. And I hope, a lot of you aren't moving because then I need to keep track of every time somebody moves, right? So this is traditional routing protocols. It means very big fib TCAMs because I need to store all the routes local to me. And anytime somebody moves, that's a control plane routing update, okay? And imagine I do this with BGP, right? BGP is a wonderful protocol. Every time somebody moves, it's a BGP routing update, okay? That's the reason we did not choose traditional routing protocol. Lisp, on the other hand, is that mapping system, and it is an on-demand routing protocol. So all it cares about is what routes are locally connected to me, right? I've got some number of hosts that are plugged into me, and then I got to know where the control plane is, the map server, okay? If I ever need to get somewhere else, I just ask the map server, where's the data center? Oh, it's connected to border 2. Cool. I'll go to border 2, okay? So it's very, very lightweight and custom built for these. Now imagine this is your poor 3850. Does anybody know what the TCAM size is for a 3850? No? Nobody? Okay. 8K. So in other words, the size of your total domain would be limited to that 8K. It doesn't really matter. You just get the point. If I tried to run full-blown BGP routing on a 3850, he's not going to do very well. Okay. Moving on, you get the point. It's on-demand, optimized for a host mobility environment, okay? Now, in Lisp terms, what I've been calling a control plane is actually called a map server, map resolver, okay? Whenever the device first registers, that's the map server, and then if somebody asks where that device is, he's the map resolver. Pretty straightforward, right? Now, what I've been calling edge nodes, what I've been calling edge nodes and internal borders are called tunnel routers. Now the X in this name just simply means, is the traffic coming to me, ingress, or is it headed out from me, so egress. So we just typically say XTR, but more importantly, it's a tunnel router. And remember, he's the one that takes that address and registers it with the map server, okay? We've been talking about it, so it's very simple. Now, the other one we talked about, and I called it the external border, is this proxy tunnel router, okay? And it's exactly like we described, right? It's that I have nothing else left in my list, so just send it to him, he'll figure it out, okay? But now you know the official names. If you hear somebody say Lisp map server, or Lisp tunnel router, Lisp proxy tunnel router, you can translate that whole control plane, border, and edge terminology, okay? The other thing you'll hear us use is endpoint identifier. That's your address, IP v4, v6, and the routing locator. And this is simply your loopback address. This is how I know to talk to your router, right? So when I talk about that mapping, I map his endpoint address to the routing locator. Simple as that. Easy peasy. Who knows the entire BGP AS path selection algorithm and isn't here to take the CCIE test? Okay. There are 6 distinct Lisp messages. Super duper simple. Okay, I'm not going to give you, like I said, this is not the full Lisp class, but I'm just making a point. Lisp is very lightweight, very simple, very straightforward. Okay, look up reply, look up request, look up reply. There's changes, like if a map entry changes, it's called a solicited map request, these kind of things. Very, very lightweight. Okay, clicker's being weird on me again. So this is a picture of, and I'm using, again, the terminology, but this is a ETR or an ITR based on Lisp terminology. And what I have is I have a stretched subnet of this entire 10.2/16, okay, stretched across my entire fabric edge, right? And what happens, remember, the first thing, the client gets plugged in. So the first thing that happens is they register. Hey, Sean's laptop is currently on switch number 2, okay? In this example, because trying to make it simple for everybody, I'll continually keep referring to this 10.222 host. That's why he's glowy. And then his registered edge device is 2121, okay? So eventually, somebody in the branch is going to say, I need to talk to 10222, right? So that edge node, which we call the ITR, because it's coming from him, it's its ingress, is going to say, hey, where's 10222, right? And he just asks the control plane node, the map server, who will reply, and this is the whole magic of it. It's not even complicated. I'm making it simple on purpose, with his loopback address, 2121, right? Now, the other interesting thing on this slide, it's subtle, but look beneath the where is 10222. He doesn't know at that point. One of the key items of Lisp is that we will cache the entry. So it's not like I'm asking the control plane constantly, right? And if you think of like a DNS cache, it's the same thing, right? This lives for 24 hours by default. It can be changed, but for the next time interval, I have my entry local to me, and I can just directly send it, okay? All right. Now, same kind of thing. You got the branch office. He's going to talk to 10222 at the bottom. The only value of this particular slide is step number 4, okay? Because I'm trying to visually illustrate that I've added an additional IP packet, an outer IP packet that travels across this IP network. So everything in the middle, those goofy HP switches that you have, all they see is a packet, an IP packet from 111 destined to 2121. And that's it. Simple as that. Finally gets to the other side. He takes off that outer header. It's back to the original packet. That's how Fabric works, okay? Now, the next one is about mobility. So you say, okay, you keep telling me about mobility, and you know, it's great if everybody's sitting at the same place, but they have to move around the network, right? So how does that actually happen? And there are some hidden slides. I know some folks are looking at the hidden slides that I try to give better detail. But when he initially comes on, just like I said, he's going to do a register. And what's interesting here, the part I want to draw attention to is the /32, right? This exact host address is local to me. I'm going to register them. The control plane says, okay, cool. In this example, the locator address is 12211, 111, right? Traffic's flowing. You've seen this part. But what happens when he moves? Well, if you think about it, that same registration has to happen. So he just follows the same basic rules. So the new edge says, oh, he's connected to me. Let me register him, right? Now, the control plane is smart enough to say, oh, somebody else registered him, right? Same thing happens. Now, the last part, so the interesting part about the slide, it animated through, but I wanted to catch it, is for the control plane to actually notify the original edge node that, hey, you don't have him anymore, right? And the reason for this, people say, well, why did you do that? This host here, when they were on the same edge node, he didn't have to encapsulate it. He was just sending it natively to him. But now that it's moved, if this host wanted to talk to him, he needs to encapsulate. So that's why we have to also tell the old guy that he's not there anymore. But it's as simple as that. And then everything else is exactly the same. I encapsulate it. It's now from 12221 destined from here. Simple as that. Okay? Now, in each one of these sections, and I said that these are all based on standard technologies, and you can Google them. You can. What I wanted to do is also show you how they've evolved and how they're a little bit cooler for SD access. Okay? So if you look at traditional Lisp, the actual Lisp in the RFC, it was built for layer 3. So it defines VRFs, it defines IPv4 and IPv6, makes no mention of layer 2. Okay? But I keep saying I've given you layer 2. So, and particularly the wireless. So if you are a wireless person, you know that client roaming is based on MAC address, right? So one of the key enhancements made to Lisp in SD Access is focused around layer 2 and wireless roaming, okay? Are those enhancements proprietary to Cisco, or are they part of the standard? As of this moment, they are proprietary to Cisco. But I love this discussion because I always say, like, who invented MPLS? Who makes standards? Cisco makes standards. And then they get kind of congealed into some standards body, which is important on its own. But there's always a a delta. There's a point where something is new, and then it gets standardized, and then something's new, and then it gets standardized, right? And you're just in that delta time. But yes, straight up answer, it's proprietary right now. Okay, moving on to the next part. So that was Lisp. Why Lisp? What does it get out of me, and how is it different? So the next part is VXLAN. Now, in this particular picture, it's kind of obvious, but what I'm trying to draw attention to is when I send this original frame on the LAN, it includes my Ethernet header, my frame header, my source MAC address destined to some other MAC address, right? Probably the router MAC. Lisp, standards-based Lisp, also has its own special fabric header. I can actually even put VN, VRF, and SGT into the Lisp header. But it's a routing protocol. It was built for routing. So routers don't care about MAC addresses. The very first thing they do, that's in a different IP subnet, throw away the Ethernet frame header, put my routing header on it, right? So in other words, when you see that picture, Ethernet just disappeared, okay? So one of the two reasons, but one of the first main reasons we chose VXLAN, it was built for the data center. It was built for layer 2, okay? So in one of the hidden slides, I have a side-by-side of Lisp and the VXLAN frame, and you can see that they are 100% identical, the difference being that VXLAN carries the Ethernet header, okay? So, and like I said, that's one of the two reasons, but in essence, this is how I give you layer 2, because when it comes out the other side, I still have the original Ethernet source and destination. So the client thinks he's truly talking layer 2, okay? This one's just kind of cute, but it elaborates on the same picture, right? So the blue is what the outside world sees. It's regular source destination MAC, and the source dest IP are those routing locator, my loopback address talking to your loopback address, right? Now, it is an IP UDP frame. Again, it's all standards-based. But what's interesting about this is it's a special destination port. So when it gets to the other side, he says, it's a VXLAN frame. Let me poke in there and see what else is in there, right? And that's where the magic happens. So embedded inside of the VXLAN frame are fields for what they call segment ID, which we call SGTs, and VN IDs, VRF VPN IDs, okay? And that's the whole magic, really, right? But by doing that, I've now given you layer 2, and I've given you embedded security and policy, okay? There's some interesting things about how it's triggered, but I'm looking at the clock, and I want to save you some time. So again, same thing. If I go and look at the exact Lisp spec, or if I look at the VXLAN spec, the key difference there is they don't natively carry SGT. That segment ID field is not used, right? But we enhanced it, and this is, in fact, a good example of an evolving standard. There is a IET draft for VXLAN GPO. So you can go Google VXLAN-GPO, and you will find this. But in essence, that's how I gave you L2, okay? So, and then I said it was one of two reasons. So the other, and we just talked about it, is packing that VRF and SGT into the VXLAN frame, okay? Now we've talked through this, so I don't want to belabor the point, but again, VRFs and VNs means isolation, right? So my goal, my value, and this is you, the IT administrator, going home, talking to the boss, is, hey, I can give you the same things MPLS could give you, and I can protect our infrastructure. And we'll just have a conversation about, hey, let's put these in these VN and put these others in these other VN, okay? Now, inside the VN, or maybe I don't care about VNs, and I just want to have one giant VRF, that's fine, right? But inside here, now I need to provide actual security. And it's really about who can talk to who, right? And that's where the scalable groups, and particularly scalable group access control, comes in, okay? Now, when we talk about policy and SD access, it's access control. It's the first thing that comes to everybody's mind. That's usually what you mean. But it's also quality of service. Now, they renamed it to application policy. Everything's like app experience, you know, app location, app this, app that. But in traditional terms, it's quality of service, okay? So for a particular application, I'm going to give him this service level agreement, and I'm going to have this kind of queuing behavior, okay? There's also traffic copy. I don't make a big deal about it, but this is span, right? So there's some suspicious traffic or something's happening, and I want to span that traffic off, okay? Now, the number one question comes, and there's hidden slides. Again, there's a whole security session on this, so I don't want to go too far. But how do I actually get into this group? There's two ways I can get into this group. The first one, which is where you should be moving, is a dynamic classification, right? And this is all the names, and this is where the Cisco ICE comes in, right? The gentleman's question earlier. You know, there are a variety of existing authentication and authorization methods available. And if you're not familiar with that term, what it means is authentication is like, are you a good guy? Yeah, Sean's a good guy. Okay, now I authorize you, right? And authorization is like the result, if, then. If Sean's good, then put him into the marketing group and give him this IP pool. Yeah, question? Right, so his question is, if you don't have that availability, is there like some kind of interrogation or some other options? There's a whole host of things here. There's also, you know, device sensor and device profiling, right, which is the most common one. We talked about IoT, so there's CoAP and MUD. And, you know, there's a whole host of things. Like, I can't even remember all of them, right? But there's a variety of methods. But what's important, what's good about your point is it's not one thing, right? It's actually when you get down to this level, it's going to be a bunch of different things combined together, right? And that's even where I was going with the story. You say, okay, well, that sounds great, but I don't even have that. Right now, I'm putting switchboard mode access on ports, right? Like, who's doing wired.1x today? Wired. Yeah, a fair amount of you. Okay, so you're actually in a good spot. But who's still doing static VLAN assignment on interfaces? And don't be shy. Okay. So, but that's a form of identity in itself. You're saying, and usually what we do is we set up VLANs and we give them VLAN names and we call this the nurse's VLAN, right? And we intentionally set port 12 into the nurse's VLAN. So we have a mental sense of port 12 means nurses, right? So it's still that same kind of thing. You're on a path towards identity in that sense, right? And then as the org gets bigger and bigger, and and then to your thing, maybe it's a whole bunch of things. Like over here, I have some weird IoT devices, and I have to use this other protocol and LLDP or something to identify it, right? But then on my wireless infrastructure, because it's easy, I'll start doing .1x. So it's going to actually be a bunch of these together, okay? So, but now I've got them into groups. That's the whole point of the story. Sean's a good guy. I know about Sean. I'm going to put him in the marketing group. Now I have this tag called marketing, right? And I don't actually care if Sean is on this IP subnet or that IP subnet, because that's what a traditional access list means, right? Who's built access lists? Who loves access lists? You kind of thought about it. Nobody loves access lists, at least in the very long form, right? Creating some access lists is kind of cool. I get it. But if my day-to-day job is to go out there and manually manipulate a bunch of, you know, this, maybe it's a subnet, maybe it's an exact host, you know, any TCP this, da-da-da-da-da, greater than, and I have like 20,000 lines of that. Who has more than like a 10,000 line ACL in their network? A few of you, okay. So you get it, or you just never touch it. Some guy like 5 years ago wrote it, and you're like, I'm not gonna frickin' mess with that thing anymore. And it's broken, unless it's broken, you get the point, right? So here I'm using plain English words, but it's the same logic. It's from a source to a destination with some kind of application, right? They use the word contract, but by contract they just mean the application I'm trying to use, right? Now I intentionally added the APIC DC because one of the things we do from an ACI integration, this is not the ACI integration session, but we can import EPGs from ACI, right? So they've defined, and they have a very similar group-based model, which they call endpoint groups, EPGs. And I can actually learn those and import those into DNAC, and I can set up a policy from, in this example, guest to web users, okay? But you get the point, right? Okay. Now this is a cute little animation, and it's only meant to drive home the point I described earlier, that there is this underlay IP network, and it doesn't actually have to know virtual networks or SGTs, right? Because all he's seeing is that outer VXLAN frame that has the VN and SGT inside of it, right? So when the user comes in, I figure out it's Sean, he's in marketing, marketing's part of employee virtual network, I pack that into the frame, carry it over, and then I unpack it, right? Simple as that. And now I can have an ACL that says, okay, Sean or group marketing is allowed to talk to the web servers, something like that, okay? All right, so Cisco TrustSec already exists. Who's actually deployed Cisco TrustSec in its native form? 1, 2, 3, 4, there's quite a few, okay. What were your biggest challenges? Just shout it out. Nothing particular, it was just awesome? Keeping metrics and all the different devices, okay. The reason I'm making the point, TrustSec itself is awesome, but we ran into a lot of complications around it, right? So it only kind of partially got off the ground. We really think that SD-Access is what's going to take TrustSec to the next level because of the overlay kind of thing. So I don't need to put on tagging hop by hop by hop, right? And the different metrics and how do I keep track of that, scale issues, these kind of things, right? The other thing is, it's continued to evolve. So now having firewalls that are SGT aware and these kind of things. So as this continues on, the SD-Access version is much more advanced, okay? But the same value proposition that you get. And his question is, or statement is, Checkpoint is SGT aware as well. It is SGT aware, absolutely. And there's one of the sessions, the connecting to outside is all about connecting to firewalls and doing those kind of things. Okay, like I said, this was kind of the last bit, and it's going to dip down really fast. Plus, I also told you I wanted to show you a demo, right? So I'll go through this pretty quickly, but I'm going to drive some key points here. So first is this big picture. I always wonder to myself, should I put this slide much earlier, or should I just kind of save it to the end? And you remember that picture that had the DNA center and ICE at the top, and then I had the big campus fabric at the bottom? This is that same picture in reverse, right? So I've got the routers and switches at the bottom. That's my campus fabric. I'm really going to focus on DNA center and ICE now, okay? So you buy the DNA center, and the first thing you get, obviously, is a sexy graphical user interface, right? I'm going to show it to you, but it's a brave new world, okay? What can I say? But in the end, it's a front end. It's a GUI. Now, on the back end, there's an individual component called NCP, and if you poke around, you'll run across this inside of DNA Center, but it doesn't get talked about much. But it is the automation subsystem, okay? Its sole job, just like any other automation box, is to go out there and push configs, okay? Now, one of the cool things about a controller is, it can speak in the language it needs to speak. Right? And the reason I'm making this point is, I remember I've got some Cat6Ks out there, I've got some 3Ks, I've got my new Cat9Ks. So where appropriate, it will use advanced things like netconf and yang, right? And if it's something legacy, I can just use regular SSH and configure good old CLIs, right? But it'll know what to do. It goes out, it programs the campus fabric, okay? Now, also embedded into DNA Center is this NDP, and the acronyms aren't very imaginative. It's the Network Data Platform. But this is your management and data analytics subsystem, right? And this is another slide where I always remind people, you know these things, okay? Today, you're probably using SolarWinds or Prime or HP OpenView or something. You're sending syslogs at it. You're sending NetFlow at it. It's probably doing SNMP polling. Guess what this is doing, right? It's a NetFlow collector, a syslog collector, does SNMP. Again, kind of with the newer stuff, there's a thing called streaming telemetry, but it also does streaming telemetry. Now, what's most interesting about this is really the internal APIs. And the reason I make that point is then there's Cisco ICE. Now, ICE is its own thing, okay? It is too big and too specialized for us to ever try to rebuild ICE. That's reinventing the wheel, and we probably won't do a good job about it, right? So let ICE be ICE, But let's use some of the key elements of what ICE does and all of this Cisco TrustSec stuff, right? So particularly learn about its identity, so all of its normal .1x host onboarding stuff. And then once I know who you are, put you into the right group, and then let ICE go down and program the switches, okay? And again, it's the things you know. It's AAA, it's radius, TACAX, these types of things, okay? But what's most important of all, and it's not like super fancy on the slide, but it's these APIs, right? Because remember, I said in the beginning, what makes SD access? I said, you know, I can have a fabric, I can do all this myself, I can have a different automation system, I can have a different management system, but tying all of this together is the real value, okay? So, one last thing is the, again, kind of subtle, but I can interoperate with a lot of other systems. So a lot of people ask me, like, you know, can I use HP ClearPass? Of course you can, right? What it means is that ICE is the one that he's the man in the middle, right? He's going to talk to DNA Center. He's the one that's actually pushing via radius the policies down to the switches. But the AAA part, the authentication, can come from ClearPass. So it's called AAA proxy, if you've heard of it, okay? It's just an example of how we can actually expand this into a much bigger system, right? Similarly, we can integrate with like live action, SolarWinds. So I have all this other cool data that my company already has. Can I integrate that with DNA Center? And the answer is yes.
What would you tell a customer that's using Cisco Prime right now to manage much of their wireless infrastructure, but they're going to SDA? What kind of integration would Prime have? Will it be able to talk to the DNAC to get more information, or should they just go completely to the DNAC for their management?
So his question is, what if a customer is using Cisco Prime today, and what would you tell them about integrating with Cisco Prime and whether they should ultimately, where are they going with Cisco DNAC? There are DNA Center sessions. I'll start with that. Go to the DNA Center session and ask that question. The short version is that there can be only one. Anybody seen the movie Highlander? Okay. I make this joke a lot. Yeah. So, but his other point was there, you know, you've invested a lot of money, and there are still a lot of wonderful things in Prime that have not yet made it to DNA Center, right? And it takes time. The other thing, and I actually usually make this point, like, guys, this is not like overnight. Rome was not built in a day, okay? BGP took 20 years to mature, okay? So there's still things that we're bringing, but in the end, there will be DNA Center. Now, having said that, there is a bunch of back-end APIs. In fact, I think there's sessions dedicated to integration of Prime and DNA Center. So that's definitely a top-of-mind kind of thing. But check with those guys. It's from the DNAC team. OK. Again, I want to save some time for you. So, and this also will be in the DNA Center sessions, so I don't want to belabor the point. But we actually sell 3 different models right now. As you can see, like I said, if you ever see asterisks on a slide, look around. The M4 series of UCS servers, this is a big UCS server, is being discontinued. Therefore, our UCS M4 version of the DNA Center is going away as well. But there is a corresponding 44-core M5, which is now this DN2. So this is why actually I put the slides in, was just to make people know. L, it stands for large. I think you get the point, and you can see the scale from there. And then starting with 1.3, we've introduced this XL model. So the table just moves over. Again, it's all DN2, but you have the base model, the L, and now the XL, right? So there's another session and several other parts on design. There's a whole 4-hour session. I think I see a couple of my guys from my design session. Even then, we couldn't possibly get over everything in 4 hours. So obviously, I can't give you every design detail, but you get the basic concept, right? Small, medium, large. You get it. It does support high availability in the form of clustering, a 3-node cluster. We know it can support more in the future, but right now it's 3. People say, why 3? And some wonderful language like an odd number to achieve quorum, whatever the heck that means. So I tried to redefine it down here on the bottom and say, look, 2 nodes are active and doing work, And then the third one is the backup, the redundant one, right? Yes, and his question is, or comment is, you cannot stretch that across data centers. They must be L2 adjacent to one another. Close to adjacent. Yeah, and it's like 10 milliseconds or less, yeah. Yeah. You gotta speak up a little bit, sorry.
So what if you have in a larger environment, like you just keep adding to the cluster?
Good point. So his question or point was, what if I have a really big environment, can I keep just adding to the cluster? So there's two ways to look at this, and this is another one of those kind of like ask the DNAT guys more than me. They'll have the more straight up current answer. But architecturally speaking, and what's hidden in here is this microservices based on maglev, and why is it a cluster? So the original intent is precisely that, and that's why it talks about more and more in the cluster. But it's also super duper complicated how these little microservices talk to each other. So the more expedient way to achieve scale was to give you bigger appliances, right? So it's somewhere in between there, right? First things first was to get you bigger appliances that you could just out of the box get scale. And then as time goes on, to enhance the clustering piece of it. Yeah. I would like to save time for any design-related questions. I know this is a super important question, but I also know it's a black hole. So, and what I'll do, I always kind of set up a queue outside. I know there's a bunch of super important questions. So if you have time, and I see people already escaping, so I'll set up outside, and then if you want to hang around, if you can hang around, I'm happy to answer the long, dirty questions. Okay? Yeah, and that's why I want to get onto the demo. I'm just trying to save it. Okay. Of course, it timed out, so I need to flip over and log in. Maybe. And you guys know how live demos work, right? I hope it works, and I hope I remember my password. Yeah. No, it came slowly, maybe. Well, and I made the mistake of being on Wi-Fi just because I got here kind of late. I was going to set up on wired. There's no stick on wireless or anything, but there's a lot of people in the room all on Wi-Fi. Okay. So because of the time, it will be kind of the rapid fire version. And I guarantee there are other examples of this all over Cisco Live, right? So even in the world of solutions, there's labs. Thanks for the folks who are running off. Still got a few minutes. Okay, so inside of, in the longer version, what you would do is you go through design and policy. But remember, this is the rapid fire version. Design is all about your global settings, right? And you define what your AAA server is, since that's the first one on the screen, but also your syslog, NTP, DNS, DHCP. These are the things you have to go down on the switch and copy and paste, right? If you're smart, you've created a template and those kind of things. And it's saved across the hierarchy. And the reason this is important is anything below it just natively takes that setting. Or I can go lower in the hierarchy and I can create a local configuration for that location, that site. And then in policy, this is where your virtual networks are set up. And this is also where you would take the devices themselves, the groups, and put them into their corresponding virtual network, okay? Now, when I hit save, what it's doing is it's actually going out there and programming the VRFs for me on all the access layer switches, and more importantly, on the borders, having the VRFs defined so I can hand them off to someone else, okay? And again, this is the rapid fire version. When you get into group-based access control, right? Now, what's important here is, again, that plain English source to destination of group names, right? Nowhere in here am I talking about a VLAN or what its IP subnet is or that stuff, right? It's simply, whatever. Maybe it's, doctors to nurses, right? And you can search too. That's another cool little, but it's, it's a GUI. So apparently I have 2 nurses. Call it doc to nurse. Now, the other piece which I talked about is the application, right? So it's source to destination with some kind of app, right? And if you don't care, you don't do anything special, it's just basic permit deny logic, right? But if you go out there, then you can specify the exact protocol type that it's using, right? So in this example, I've already set up HTTPS, so I'm just going to use that one. And so what that literally, it'll be access control entry, if you guys know ACLs, that'll say, permit port 443 and deny IP any. That's what it'll end up looking like, right? But I didn't have to type any of that, right? I hit save. This is a on-purpose warning. Everyone oh my God, his demo screwed up. No, it's telling you ACLs block traffic. Do you really want to push this ACL? Yes, I do. Okay. And then it goes out there and it applies that ACL on the switches, okay? Now, the other part is in provision. Provision is broken into devices, which I equate to the underlay. Remember, DNA Center is bigger than SD Access, right? So they kind of have their own language. But this is device management. So it's all the things you think about device management. It's inventory, it's software management, and a dozen other things, right? But in the end, and this is also where that LAN automation stuff kicks in, right? So if you look under the actions, I can do things like run LAN automation, and then it'll go out and it will discover via CDP and LLDP all the switches that are there. It'll automatically bring them online. But this is the underlay, right? This isn't anything fabric. I need to do these things so these switches and routers and wireless are part of this location now, okay? Then I skip over to the fabric section, okay, when it loads. It's divided into 2 parts. There's a whole session on multi-domain. If you're curious, please go to the multi-domain session. But effectively, I can create one fabric, right? But I have a big company, right? So I'm probably going to end up having a whole bunch of fabrics, and then how do I connect those fabrics together? And that's what transit areas are, okay? So I'm not going to overcomplicate that. I know that other session will deal with that. But here, you see the hierarchy again, right? And then I can go to my specific locations. I'll zoom in because I know it's hard to see back there. And this is where your various devices are and what role they are. And this is where I was talking about, we've moved to just a simple toggle. For anyone who's seen 1.2, they've never seen this particular UI. This is a brand new UI. If I do the border, then I at a minimum have to configure a transit area and which interface that I'm going to use. This is where I was talking about, I can either turn it into what we would in the old days call an external border or not, right? If I don't, it's a internal border, right? Add my transit. Oh, it wants it doesn't need the IP pool if I do SDA transit. But if I do an IP transit, then I have to define the external interface. This is a slightly longer version. You only have to do this every once in a while, but it's still saving you a bunch of crazy BGP configs, right? This is also where it's the border, right? So I'm telling it which VRFs I want to expose outside of the border, right? Once I've done that, it goes through. Now, interestingly enough, this is more about like the UI. It's still gray because I haven't actually configured it. It's when I hit this, and I can choose later, and I can do time-based. A lot of people ask, like, what about change control? What if I need to do this at midnight or something, right? But I'm just lazy, so I'm going to do it right now. And that's it. Meanwhile, it's out there. It's pushing all of those Lisp and BGP configs and all of the interfaces and those kind of things. If I had more time, which I don't, I would take you on a whole journey through assurance and the wonderful things. So at least you got to see that. Let me flip back over. What I wanted to get you on, because that was the part I just showed you. There's your live demo. The takeaways. Remember, SD access, campus fabric with DNA Center, right? There's a ton of routers and switches and wireless out there available to you. We talked kind of on the way about what's new in 1.3. I said this to you, but I wanted to actually show you a screenshot. This is the Marriott Hotel running SD Access. So if you find yourself in the Marriott, SD Access is there. What to do next? Normally I tell people, look, you don't have to do this tomorrow, right? What you really should be doing is thinking about your hardware. You're going to go through normal refresh cycle, right? So get yourself the right switches and routers and wireless, get the right software, et cetera. And DNA Center is bigger than SD Access as well. You can turn on DNA Center and just look at assurance, right? Or maybe I'm just using software image management or something, right? Get used to the tool, see how it works. Then when the time is right, turn on the fabric, okay? There's lots of stuff online. There's a bunch of other sessions. I showed that to you guys. There's also this WebEx Teams. So if you think about something later, jump on there and I'll answer your question when I can. And that's it. Thank you very much.